Good morning, students. Today we will start the topic projectile motion. So, very important concept for 5 marks, 3 marks, and also for the problem, right? So, what is projectile motion, right? So, first we know motion. So, displacement of the object from one point to the another point. That one we call as the motion. So, what is projectile motion, right? So, if any particle moving with an direction making an angle theta with the horizontal, then that type of motion we call as the projectile motion. So example for the projectile motion, as already said, that is football kicked. When football is kicked, the path traced by the football, so that path we call as the projectile motion. So that one we call as the example for the projectile motion, right? So that is in the form. So if we consider this one is in the ground, right? So it follows the path like this, right? So this one we call as the projectile motion, right? So what is projectile motion? Any particle moving in a direction making an angle theta with the horizontal under the action of gravity. This will also include, right? ಸೊ ಯಾವುದಾದ್ರೂ ಒಂದು ಪಾರ್ಟಿಕಲ್, ಸೊ ಅದು ಯಾವುದಾದ್ರೂ ಆಗಿರ್ಬೋದು ಪಾರ್ಟಿಕಲ್, ಸೊ ಅದು ಟ್ರಾವೆಲ್ ಆಗ್ತಾ ಇದೆ, ಯಾವ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಆಗ್ತಿದೆ, ದಟ್ ಈಸ್ ಇನ್ ಎನಿ ಡೈರೆಕ್ಷನ್ ವಿಚ್ ಮೇಕ್ಸ್ ಅನ್ ಆಂಗಲ್ ಥೀಟಾ ವಿತ್ ದ horizontal, right? So horizontal means along x axis, we call this one as the horizontal, making an angle theta with the horizontal under the action of gravity. So now ಯಾವುದೇ ಆಬ್ಜೆಕ್ಟ್ ನ ಥ್ರೋ ಮಾಡಿದ್ರೆ ಅದು ಮತ್ತೆ ಎಲ್ಲಿಗೆ ಬರುತ್ತೆ, it comes back to the ground. So that is due to because of the gravity of the earth, right? So this one we call as the projectile motion. So here if example, so take down this example, when football is kicked or a ball is thrown by a fielder, right? So or the javelin throw, discus, so these are all comes under the examples for the projectile motion, right? So here we are going to discuss few definitions, right? So path or trajectory followed by the object, that one we call as the projectile motion, right? So next, the time taken to the displacement of a body from one point to the another point in two dimension of motion, so that one we call as the time of flight. So what is time of flight? So time of flight ಅಂದ್ರೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನಾವು ಥ್ರೋ ಮಾಡಿದ್ರೆ ಅದು ಎಷ್ಟು ಟೈಮ್ ಸ್ಪೇಸ್ ಅಲ್ಲಿ ಇರುತ್ತೋ ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, time of flight, right? So when an object is thrown or the object is projected, so at the what time that is in the space, so that one we call as the time of flight, right? So next one is the range, the horizontal distance which covers by the projectile, so that one we call as the range, right? So what is range? Range is the horizontal distance which is covered by the object, that is when it is projected, only the horizontal distance na ನಾವು ಏನಂತ ಕರಿತೀವಿ, range ಅಂತ ಕರಿತೀವಿ, right? So next one is the height. So what is height? That is when the projectile is projected, it covers the vertical distance. So maximum vertical distance which it covers, so that one we call as the height, right? So this one is the height of the projectile, right? So these are the three important definitions. So range means horizontal distance covered by the projectile. So horizontal distance na ನಾವೇನಂತ ಕರಿತೀವಿ, range. So height, the vertical distance, covered by the projectile. So ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ height, right? So time of flight, the time taken by the projectile in the space. So that one we call as the time of flight, right? So ಇದು more important definition. So here, so ಈ path ನಮಗೆ ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆ ನಮಗೆ? So path projected by the object or projectile ಯಾವ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆ ನಮಗೆ? ಯಾವ ಶೇಪ್ ಅಲ್ಲಿ ಇದೆ ಇದು? In which shape it is? Circular shape. So it is in the shape of the parabola, right? So parabola shapes you try ಮಾಡಿದಿರಾ ತಾನೆ 10th ಅಲ್ಲಿ. So these are all the parabolic shapes, right? So path of the projectile is the parabolic shape. So ಇದನ್ನ ನಾವು theoretical ಹೇಳಿದ್ರೆ ಇದನ್ನ mathematically ಕೂಡ ನಾವು ಏನು ಮಾಡಬೇಕು ಪ್ರೂವ್ ಮಾಡಬೇಕು, right? So that one is the important for 5 marks derivation. So theory ಒಳಗೆ ನಮಗೆ 5 marks ಗೆ path of the projectile is parabola, right? So that one is very important. So now show that the path of a projectile is parabola, right? So consider any one particle, it is thrown with some velocity. So taken that velocity as u, right? Thrown with some certain velocity. So here it covers the maximum range and it covers some height, right? So now resolving this velocity along the horizontal component and along the vertical component. So ಈ u ಅನ್ನ velocity ನ ನಾವು along horizontal ಮತ್ತೆ along vertical ಆಗಿ resolve ಮಾಡ್ಕೊಂಡ್ರೆ along x axis we get the component of velocity, that is u cos theta. So in the same way vertical ಅಲ್ಲಿ ನಾವು resolve ಮಾಡ್ಕೊಂಡ್ರೆ u sin theta. That means we have the two velocities. One velocity is along the horizontal and another velocity is the vertical. So horizontal velocity we taken as u cos theta and the vertical velocity we taken as u sin theta, right? So for the total time of flight, that is denoted by capital T, right? So initially we taken velocity of projectile u, right? So this can be written as u is equals to ux I cap plus uy j cap, right? So horizontal velocity we taken as ux is equals to u cos theta and uy is equals to u sin theta. So for our reference, the position of the particle is starts from the origin, right? So initial position of the object is we projected, so that one is started from the origin, right? So if we write the displacement equations for those, we have x that is equals to xo plus vox plus half gt square, right? So it is a vertical motion, so hence we are taken minus of gt square. So this projectile is moving under the constant acceleration, so that one we taken as a is equals to minus g j cap. So this gives what? Velocity, and here we are written the acceleration. So this projectile is moving under the constant acceleration. So here we getting only the vertical component. So if you observe here, acceleration along x axis is 0 and the acceleration along y axis we getting minus g. right? Because here I cap is 0, right? So only we have x component, that is 0, and y component is minus t. That means it is moving under constant velocity. So this object is moving under constant velocity, means that acceleration is 0. Constant velocity means initial velocity and final velocity both are same. So when these two are same, then the acceleration along x-axis is remains constant. So that's why we taken that as 0, right? So here initially I will write ax t square, right? So same wise, vertical direction y is equals to y naught plus voy minus half, sorry, plus initially we take ay t square, right? So these two gives what the displacement. So here we get the velocities and here we are getting the accelerations, right? So now initially I taken starts from the origin, that means x component and y component is 0 comma 0, so that means these two values are zeros, right? So and also along x axis we have the acceleration is 0, right? So if we write the displacement x, that is equals to vox. So vox is the velocity which is along the x axis, so that one we take that as u cos theta into t, right? So that is ut plus half a t square, right? So plus, that is plus into minus, minus half, so ax is 0, so whole term here we get the 0, right? So directly we can write x is equals to u cos theta into t. So next y, that is equals to y naught is also the 0, so y over is the direction of the velocity along the y axis, so that's why it is u sin theta into t, right? So plus into minus, minus half gt square, right? So this gives what the displacement along x axis, y gives what the displacement along y axis, right? So next, for the time taken to cover the x distance, so from this equation, calling this one as equation 1, equation 2, right? So for the from first equation, t is equals to x divided by u cos theta, right? So ಇದನ್ನ rearrange ಮಾಡಿ ಬರ್ಕೊಂಡಿರೋದು time, that is equals to displacement by velocity x by u cos theta, right? So substitute this in equation 2, so we get y is equals to, so wherever t we need to substitute x by u cos theta, right? So that is u sin theta into x by u cos theta minus 1 by 2 g into x by u cos theta whole square, right? So here in the numerator and denominator we have the common term u, that is it cancels, so y is equals to sin theta by cos theta, we can write that one as tan theta into x, right? So sin theta by cos theta, that is tan theta into x minus 1 by 2 g x square divided by u square cos square theta, right? So now this one we can write y is equals to tan theta into x minus 1 by 2 g divided by u square cos square theta into x square, right? So comparing this with the standard equation, y is equals to ax minus bx square, right? So this is the equation of the parabola. Comparing this equation with the equation of parabola, we have the same terms, right? So in place of x we have x, and in place of x square we have x square. So where a is equals to tan theta and b is equals to 1 by 2 g divided by u square cos square theta, right? So this gives what the equation of parabola, right? So we need to prove y is equals to tan theta into x minus 1 by 2 g by u square cos square theta into x square. So this is the equation for the parabola, right? So important for 5 marks. So ಇದು ನಮಗೆ mathematical equation. So maths ಅಲ್ಲಿ ನೀವು ಸ್ಟಡಿ ಮಾಡೋ parabolic equation y is equals to ax minus bx square. So ಇದು similar to that of the projectile motion, right? So in place of a we have tan theta and in place of b we have g divided by 2u square cos square theta, right? So important concept from this we need to remember is acceleration. We have a is equals to minus gj cap. So minus because it is in the vertical motion, right? So ಯಾವುದಾದರೂ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ ನ ಥ್ರೋ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ it travels along vertical. So ಇಲ್ಲಿ ನಮಗೆ horizontal acceleration ಏನಿರುತ್ತೆ 0. So if the acceleration along the horizontal is 0, that means along horizontal the velocity remains constant. So throughout the journey ಅಲ್ಲಿ ನಮಗೆ ux ಏನಿರುತ್ತೆ always remains constant. Only varies the vertical velocity, right? So if we consider at this point velocity, so I will draw the tangent at this point. So now here if we resolve the components, so here we get ux I cap uy j cap, right? So next, exactly at the maximum height, if I resolve the component, here we get ux. So then here we won't get the uy. So uy is equals to 0. That means vertical velocity at the maximum height we getting 0, right? So again at this point if I project it, the velocity is u. So again by the horizontal and vertical component. So ux I cap uy j cap, right? So this is the angle theta. So somewhere here, so direction is like this. So ux I cap uy j cap, right? So angle is minus theta. So this is u. So ನಮಗೆ maximum height reach ಆದಾಗ vertical velocity ಏನಿರುತ್ತೆ ನಮಗೆ 0 ಇರುತ್ತೆ. So in all the cases horizontal velocity is always remains the same, that is ux always remains the constant, right? So ನಮಗೆ ಗೊತ್ತಿದೆ v minus u is equals to at, right? So if the acceleration is 0, that means v is equals to u. That means the object is moving under the constant velocity. So that's why here we taken along the horizontal always the velocity is constant. So when it reaches the maximum height, the vertical velocity is 0, right? So this is very important derivation for 5 marks. So ಇದನ್ನು ಕೂಡ ಡ್ರಾ ಮಾಡ್ಕೊಳ್ಳಿ vector components. So at the maximum height uy, that is velocity along the vertical is 0. Only we have the horizontal velocity. So next important for 3 marks, we need to derive all the 3 relations, that is for the range, for the time of flight and for the height. So R represents range, T time of flight, H that is the maximum height. So for all these 3 we have the same diagram, right? So this is u, angle theta. So here u cos theta. So u sin theta, right? So when t is the time of flight, right? So we have the displacement relation x is equals to u cos theta into t, right? So same wise y is equals to u sin theta into t minus half g t square, right? So we will do now get displacement equation. So first we are going to find the time of flight. So time of flight ಅಂದ್ರೆ ಏನು? So starts from the starting point and it reaches the ending point. So it takes some time. So projectile motion ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ ಅದು ಸ್ವಲ್ಪ time ತಗೊಳುತ್ತೆ. When it come back to its original, that is along the horizontal, right? So that one we call as the time of flight. So our time na calculate ಮಾಡೋದಕ್ಕೆ relation, right? So along the horizontal, so idu kuda horizontal ide andre along the x axis, right? So object starts from x axis and objects return come back to x axis. That means vertical displacement enayitu namage object start agirodu along the horizontal x axis alla start cover some distance, but ground alle irutte tane bere edu hogodilla. So that means y is the vertical displacement. So vertical displacement ಏನಾಗುತ್ತೆ ಏನಾಗುತ್ತೆ 0, right? So vertical displacement is 0. So vertical displacement 0 ಆಗೋದಕ್ಕೆ ನಮಗೆ ಯಾವ ಟೈಪ್ ತಗೊಳ್ತಾ ಇದೆ, that is the t, right? So u sin theta into t minus half g t square, right? So ಈ ಎರಡು ಟರ್ಮ್ ಅಲ್ಲೂ t ಕಾಮನ್ ಇದೆ, so ಕಾಮನ್ ತೆಗೆದು 0 ಗೆ ಈಕ್ವೇಟ್ ಮಾಡ್ಕೋಬಹುದು, or u sin theta into t that is equals to half gt square. So in LHS we have 1t and RHS we have 1t, get cancelled, right? So remaining is t is equals to 2u sin theta divided by g. So this gives what? Time of flight for the motion of the projectile. So idu nimge 3 marks alli important derivation, 3 marks alli compulsory keltare atho problem alladru barutte, right? So for every we need to draw the same diagram and we need to write the same explanation, right? So here vertical displacement is 0, so starts from here. Further when it reaches the maximum height, right? So there is a difference. So illinda ilige hogta it maximum height, right? So there is a difference. So illinda ilige hogta it travels upward motion. So from when it reaches the maximum height it comes downward motion. So one upward motion ide, ಇನ್ನೊಂದು downward motion ide. So upward motion ಅಲ್ಲಿ ತಗೊಳ್ಳೋ ಟೈಮ್ ನ ಏನಂತ ಕರೀತೀವಿ? Time of ascent, right? So when it reaches the maximum height, so here velocity, that is uy, that is equals to 0. Vertical component velocity is 0. So that time we call as the time of ascent. So when it reaches the maximum height, again it comes back to the ground. So that time we call as time of descent, right? So this is time of ascent. So this one is time of descent, right? So now we need to find what is the time of ascent and what is the time of descent, right? So here the condition is the final velocity is 0, that is vertical component velocity is 0. So illi now only the displacement relations ಬರ್ಕೊಂಡಿದ್ದೀವಿ. Now we need to write the velocity relations. So we know velocity along x-axis is equals to dx divided by dt, right? That means we are going to differentiate the x component, right? So that is equals to d by dt of u cos theta into t. So if we differentiate this one we get u cos theta, right? So next vertical velocity vy, that is equals to dy by dt, that is equals to d by dt of, so here the relation is u sin theta into t minus half gt square. So now we are differentiating with respect to t, so we get u sin theta minus gt. So this gives what? The vertical velocity. So now time of ascent na find out ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಇದ್ರದ್ದು vertical velocity when it reaches the maximum height ಏನಾಗುತ್ತೆ ನಮಗೆ vertical velocity 0 ಆಗುತ್ತೆ, right? So that means this uy, so ಇಲ್ಲಿ ನಾವು uy ತಗೊಂಡಿದೀವಿ, right? uy ux, right? So uy is equals to u sin theta minus gt, right? So uy becomes 0, right? So 0 is equals to u sin theta minus g into time of ascent, right? So time of ascent is equals to u sin theta by g, right? So ಎರಡು equations ನೀವು differentiate ಆದ್ರೂ ಮಾಡಬಹುದು, or we can write v is equals to u plus kt. ಈ equation ಅನ್ನು ಕೂಡ ನಾವು represent ಮಾಡಬಹುದು, right? So v is what? The velocity which is along the x axis, right? So that is equals to u is what? U cos theta. So acceleration along x axis ಏನಿದೆ ನಮಗೆ? Acceleration along x axis. So we have acceleration a is equals to minus g j cap. That means acceleration along x axis is 0, acceleration along y axis is minus g. So along x axis is 0. So that means this term becomes 0. So if we write the same, vy that is equals to u sin theta minus a is what? G t. So same relation banda namge. So either we can differentiate these two equations or by the using this relation. So now e relation use ಮಾಡ್ಕೊಂಡು ಇವೆರಡನ್ನು ಬರಿಬಹುದು, right? So ux uy. So this gives what? The time of ascent. So time of ascent is u sin theta by g, right? So next for the time of descent. So time of the descent ali this becomes the initial velocity, right? So initial velocity 0 irutte. ಯಾವದರಲ್ಲಿ ನಮಗೆ time of descent, right? So v is equals to u plus at, right? So here from time of descent the motion is vertically downwards. That means vertically downwards ಅಂದ್ರೆ g ಏನಿರುತ್ತೆ ನಮಗೆ positive ಇರುತ್ತೆ, right? So g will be the positive, right? So same here v u sin theta that is equals to 0 plus gt, that is time of descent. So time of descent is equals to u sin theta by g, right? So ಎರಡು ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ನಾವು ಏನು ಹೇಳ್ಬೋದು? time of ascent ಮತ್ತೆ time of descent ಎರಡಕ್ಕೂ ಸೇಮ್ ಫಾರ್ಮುಲಾ ಇದೆ, right? So that means time of ascent is equals to time of descent, that is equals to u sin theta divided by g, right? So from this we can write time of flight that is equals to time of ascent plus time of descent. So ಎರಡು ವ್ಯಾಲ್ಯೂ ಸೇಮ್ ಇರೋದ್ರಿಂದ u ಅಥವಾ 2 minutes of time of ascent that is equals to 2u sin theta by g, right? So ನೀವು ಎರಡು ಮೆಥಡ್ ಅನ್ನು ಕೂಡ ಡಿರೈವ್ ಮಾಡ್ಕೋಬಹುದು, but this one is the simplest method to find the total time of flight. So ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೂ ಟ್ರಾವೆಲ್ ಆಗಿರೋ ಟೈಮ್ ನ ನಾವು ಟೂ ಪಾರ್ಟ್ಸ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ one is time of ascent and another one is time of descent. So ನಮಗೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಹೈಟ್ ರೀಚ್ ಆಗೋದಕ್ಕೆ ಎಷ್ಟು ಟೈಮ್ ತಗೊಳುತ್ತೋ ಸೇಮ್ ಟೈಮ್ from the maximum height in the ground ಗೆ ಬರೋದು ಕೂಡ ಸೇಮ್ ಟೈಮ್ ತಗೊಳುತ್ತೆ. That is by the relation u sin theta by g, right? So time of ascent is equals to time of descent, right? So this is about the time of flight. So next, range. So range ಗೆ definition ಏನು ಹೇಳಿದ್ವಿ? The horizontal distance covered by the projectile, so that one we call as the range, right? So horizontal distance ಅಂದ್ರೆ ಯಾವುದು ನಮಗೆ? x is the horizontal distance, right? So by taking this relation x is equals to u cos theta into t. T means total time of flight. So ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೂ ತಗೊಳ್ತಾ ಇರೋ ಟೈಮ್ ನ ಏನಂತ ಕರಿತೀವಿ ನಾವು? Time of flight, right? So horizontal range, so replacing x by r, that is equals to u cos theta into, so this is the time of flight, right? So time of flight is 2u sine theta divided by g, right? So range r is equals to 2u square sine theta cos theta by g. So we have one formula 2 sine theta cos theta. ಏನು ಬರಿಬಹುದು from the trigonometry? 2 sine theta cos theta formulas ಬಂದಿಲ್ಲ ನೆನಪಿದೆನಾ? sin 2 theta divided by g. So ಓದಿದ್ರೆ ಇಲ್ವಾ ಇದನ್ನ? sin 2 theta. So sin 2 theta we can write 2 sin theta cos theta. So this gives what? The range r, right? So r is equals to u square sin 2 theta by g, right? So in this we have one special case, right? To find the maximum range. So when we will get the maximum range, right? So if you observe here, the velocity which we projected is constant, that is u is constant and g is constant. Then the range is directly relates with the angle theta. So this r is directly relates with the theta. So in which angle if we project it, we get the maximum range. So now ಯಾವ angle ಅಲ್ಲಿ project ಮಾಡಿದ್ರೆ maximum range ಸಿಗುತ್ತೆ ನಮಗೆ. In which angle if we project, we get the maximum range. So ನಾವು ಬಾಲ್ ನ ಥ್ರೋ ಮಾಡ್ತಿದೀವಿ ಅಂದ್ರೆ, so larger distance ಹೋಗಬೇಕು ಅಂದ್ರೆ ಯಾವ angle ಅಲ್ಲಿ project ಮಾಡ್ತೀವಿ? So daily life ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರೋದೇ ಇದು. So ಅದನ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು, right? So maximum ಅಂದ್ರೆ ನಮಗೆ sin theta value maximum ಬೇಕು. So ಇದು maximum ಅಂದ್ರೆ we get the r maximum. So when is sin theta is maximum? Sin theta maximum value is to sin theta maximum value sin range is the sin theta ranging from table ನೋಡ್ಕೊಂಡಿದ್ದೀರಾ? ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ? starts from 0. So sin 0 0 0 to 1. So 0 ಇಂದ 1 ಇಂದ ತಾನೆ in between 1/2, 1/√2, √3/2. So all are lies between 0 and 1, right? So 0 is the minimum value, 1 is the maximum value. So we need sin value as maximum. So ಯಾವ angle ಅಲ್ಲಿ ನಮಗೆ maximum value ಬರುತ್ತೆ? 90 when theta is 90. But ಇಲ್ಲಿ ನಮಗೆ ಎಷ್ಟಿದೆ? theta is 2 theta. So that means theta is 45, right? So when theta is equals to 45 degree, we get the r as r maximum, that is equals to u square sin 2 into 45 degree divided by g, right? So that is u square by g, right? So this one is the special case. When we get the maximum range means we get maximum range when angle of projection is 45 degree. So if we projected an object with an angle 45 degree, then we get the maximum range, right? So in the second case, can we get two angles of projection for the same distance? So ನಾವು ಯಾವುದಾದ್ರೂ ಒಂದು angle ಅಲ್ಲಿ project ಮಾಡಿದ್ರೆ it covers some distance. So same distance ಗೆ some other angles ನಮಗೆ ಸಿಗುತ್ತಾ? That means if I throw with an angle some 30 degree, it covers some 100 meter, right? So for the same 100 meter, can we get the another angle of projection to reach the same range? ಸಿಗುತ್ತಾ? ಎಷ್ಟು ಸಿಗುತ್ತೆ ಅಂದ್ರೆ ಎಷ್ಟು? Same, right? So initially if we take them for the first projection angle theta, and for the second projection angle theta dash or theta 1. So range ಏನಿದೆ ನಮಗೆ ಸೇಮ್ ಇರಬೇಕು, ರೈಟ್? You know the range r is equals to u square sin 2 theta. So this is for the first one, for the first projectile, right? We need the same range for the second projectile. So height vary ಆಗುತ್ತೆ ನಮಗೆ. So height vary ಆಗ್ತಿದೆ ಅಂದ್ರೆ angle ಕೂಡ ಏನಾಗಬೇಕು ನಮಗೆ vary ಆಗಬೇಕು, right? So if we taken in such a way that this angle should be less than, that is angle should be less than 90. So ಇದನ್ನ ನಾವು xy plane ಅಂತ ತಗೊಂಡ್ರೆ ನಮಗೆ maximum angle ಎಷ್ಟಿರುತ್ತೆ ನಮಗೆ 90 degree, right? So if we cross this 90 degree we get into the second plane, right? So for that this angle theta, that is theta 1, so this angle we taken in such a way that only sign is positive, right? So here this is the 180 degree, 180 minus 2 theta, right? So sin 180 minus theta, then sin of 180 minus theta, sin of 90 minus theta, sin of 90 minus theta ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? Sin of 90 minus theta, cos theta, sin of 180 minus theta, it's sin theta itself, right? So we get u square sin 2 theta by g, right? So this is, if I take this one as r dash, so r dash is equals to r. So now second angle ಯಾವ ರೀತಿ ತಗೋಬೇಕು ಅಂದ್ರೆ, if theta 30 degree ತಗೊಂಡ್ರೆ one angle 30 degree project ಮಾಡಿದ್ರೆ, so next angle 60 degree project ಮಾಡಿದ್ರೆ both will cover the same range, right? So next if I throw theta by 20 degree, so the second angle 70 degree, so these two will cover the same range. So that was the formula here, theta dash is equals to 90 minus theta. So here we have two cases. So one is for the maximum range and second one is for the two ranges, same ranges for different angle of projection, right? So now 30 degree throw ಮಾಡಿದ್ರೆ ಮತ್ತೆ 60 degree throw ಮಾಡಿದ್ರು ಕೂಡ ನಮಗೆ same range ಸಿಗುತ್ತೆ, but height ಏನಾಗ್ತಿದೆ ನಮಗೆ vary ಆಗ್ತಿದೆ, right? So this is about the range. So and the last one is height. Right? So vertical component, height and the vertical component, we have the relation y is equals to u sin theta into t minus half g t square, right? So ಇಲ್ಲಿ ನಾವು vertical component ತಗೊಂಡಿದೀವಿ ಅಂದ್ರೆ when it reaches the maximum height it becomes the zero, so we need to calculate this height. So ಅವಾಗ ನಾವು ಯಾವ ಟೈಮ್ ತಗೊಂತೀವಿ? So the time which we are taken is time of ascent. So only it covers the maximum height. So ಇಲ್ಲಿವರೆಗೂ ಕವರ್ ಆಗಿರೋದ್ರಿಂದ ಯಾವ ತಗೊಂತಿದೀವಿ? Time of ascent. So this y we are replacing by h, right? So u sin theta. So the time of ascent is u sin theta by g, right? Minus 1 by 2 g. So t is again u sin theta by g. This one as time of ascent, right? So h is equals to u square sin square theta by g minus 1 by 2 g into u square sin square theta by g square, right? So g square get cancelled, so these two are the same, right? So we can take u square sin square theta by g common 1 minus 1 by 2. So 1 ಅಲ್ಲಿ half ಹೋದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ ನಮಗೆ? remains half, right? So height is equals to u square sin square theta by 2g. So this gives what? The maximum, not maximum, this gives what? The height of the projectile, right? So h is equals to u square sin square theta by 2g. So now if I write the all the relations, so range r is equals to u square sin 2 theta divided by g, time of flight is equals to 2u sin theta by g, and height h is equals to u square sin square theta by 2g, right? So all the three equations look similar. So ಎಲ್ಲದರಲ್ಲೂ ಕೂಡ ಸೇಮ್. ವೇರಿಯೇಬಲ್ಸ್ ಜಾಸ್ತಿ ಇಲ್ಲ. ವೇರಿಯೇಬಲ್ಸ್ ಯಾವ್ದಿದೆ? ವೆಲಾಸಿಟಿ, ಆಂಗಲ್ ಥೀಟಾ, g and 2, right? So first case ಅಲ್ಲಿ u square ಇದೆ, sin 2 theta ಇದೆ, g ಇದೆ. So second case ಅಲ್ಲಿ 2u sin theta by g. So third case ಅಲ್ಲಿ u square sin square by 2g, right? So and the last one is the relation between height and the range, right? The relation between the height and range. So by taking any one relation, r is equals to u square sin 2 theta by g, right? So sin 2 theta we can written as u square sin 2 sin theta cos theta by g, right? Divide r by h, right? So r divided by h, so here whole divided by u square sin square theta by 2g, right? So in the numerator u square, here in the denominator u square get cancelled. So sin theta, sin square theta get cancelled. So here g get cancelled. So r divided by h, that is equals to 2 cos theta into 2 divided by sin theta, right? So this we can write 4 cot theta, or we can write r is equals to 4 cot theta into h. Otherwise we can write h is equals to 1 by 4 tan theta into r. So this gives what? The relation for the height and range. So here is the range and h. So when they mention for the maximum range, when r is maximum, right? So if they given r is maximum, then angle of projection theta is, so maximum range ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, angle theta ಎಷ್ಟಿರಬೇಕು ನಮಗೆ? From the first case ಇಲ್ಲಿ ನೋಟ್ ಮಾಡ್ಕೊಂಡಿದ್ವಲ್ಲ, theta ಎಷ್ಟಿರುತ್ತೆ for the maximum range? Theta is 45 degree. So tan 45 is 1, that is h is equals to r maximum by 4. This is for the maximum range, right? So these three formulas too are important. So problems, almost all the problems will come under these formulas, right? So 5 marks ke problems kedidre direct ah kedtare, find the range, time and height. So they given angle theta and u, right? So formulas gothitandre just substitution and simplification. So in board exam for 5 marks. So simple derivations 3 marks ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ, ಜೊತೆಗೆ problems 5 marks ಅಲ್ಲಿ ಕೇಳ್ತಾರೆ, right? So next class problem solve ಮಾಡೋಣ, right? Thank you.